Hi everybody, thanks for the intro, thanks for the music. So I'm Nicolas Bacca, CTO and co-founder of Ledger. So my talk today will be about looking at how we can make better hardware wallet to integrate a bit more deeply into new decentralized applications. So I will be reviewing the different attacks that can be done today on smart contracts, the different problems that we have, how we can solve them. So I pretty much gave the same version of this talk at ETHCC earlier in March. So if you already were attending ETHCC, you can start playing the Olympia game on your smartphone or something else. But that's basically the introduction of a framework to start a discussion. So let's go. Several problems. So first, for those who are not really aware of how hardware wallets are working and what problems they're trying to solve, so a very quick summary. So the typical user computer is looking like that. So it's kind of a piece of scrap punched together. So if you're trying to hold the private key on this computer, you might run into some issues later. You might lose some funds. So here, the hardware wallet is performing all cryptographic integration operations inside a secure device. The idea is to prevent people from stealing the private keys first and to prevent smart malware that could either make you sign something you don't want to sign or that could just, well, make you lose money because it's fun. So the different problem that you have for a hardware wallet is that it's pretty simple to sign a transaction, but if you want to interact with a more sophisticated contract, if you are running a specific operation, you need a proper UI on the hardware wallet. And that's really the main issue there. How do we end up with a UI that matches the smart contract you are interacting with? So why do we want to look at this problem? Well, first, because it's interesting. Then because it's it's a complex problem that will tackle different steps of integration. So you want to be properly integrated into the browser. You want to provide the right information to users. And finally, well, it's a good way to protect trades and to let people handle their private keys and trade well. Decentralized exchanges are a good example of people owning their keys and performing actions while owning everything, in my opinion. So where are we today? So that's Ledger specific, but could be applied to a lot of other hardware wallets. We are basically integrated in all kind of DEX based on 0x. So the good thing with 0x is that since it's a common protocol, once you're integrated in 0x, you're integrated everywhere. So people did the initial integration, and then we can support basically all others. And then people got a hint of how to do it and implemented it for other exchanges as well. So I would say that the use of hardware wallets for decentralized exchange is pretty widespread, but the UI is not yet there. So if you are trying today to trade using a decentralized exchange and a hardware wallet, you will get a very confusing string on your hardware wallet saying you are trying to sign something with data, but you don't know what you're signing. So it's okay, if your computer is not too compromised, but if you have creative malware on it, then it's not that right. So what could you do today if you want to start playing with Ledger and the JavaScript API? So we have a nice JavaScript project which has been redesigned by Gaëtan Renaudot on our team. So if you are familiar with the old version from 1 year ago, the new one is completely different. It's actually usable and written by somebody who knows JavaScript, so unlike me. So that's something that you can use, and that's quite nice. We even have a starter kit and some documentation, so that's, well, interesting. Regarding how we manage to integrate a hardware wallet into the browser, which is something interesting to do. So we managed to hack on U2F, which is an authentication protocol, to use it to pass commands to the hardware wallet. So U2F is usually done to just perform a signature. So the idea was to replace passwords by a cryptographic signatures, and you do that by exchanging a challenge to a server, asking the server to sign your challenge, and previously registering and having the server store a private key which is encrypted and only usable by the device. So it's a common registration and authentication protocol, but here you can modify a few things. So typically, if you modify your handle, and instead of your handle, you pass a command, and if instead of returning a signature, you return a response, you can build a tunnel inside U2F. So that's what we did and what other hardware wallet manufacturers have been doing to provide an integration inside the browser. So it's a very ugly hack, functionally speaking, but it works. So since we want to access the device from the browser, that was an easy way to do it. On the negative side, we don't get events on device connection, reconnection, so Dapps will miss those kind of information and the UX could be made better. On the plus side, we get a guaranteed hash of the web origin when we use U2F. So that's something that can be used to enforce that actually an application is coming from the right website. Tomorrow, so that's something that's getting developed and that should be ready in a few months. So Web USB support will provide a direct access to USB devices from a web page. So that would be less hackish than U2F, that's the plus side. On the minus side, we will lose, for example, the free web origin. There will be a similar version for Bluetooth. So if you want to integrate today, if you want to use a device from a browser, Web USB is interesting to look at, even if it's not widely supported by everybody right now. So we have done the protection of private key when we transact, but now if we think about the different attacks that can happen when we interact with a contract. So how can we verify that we're integrating with the right website, with the right contract, with the right token, and what are the different attacks that can be done from there? So first, verifying that you're integrating with the right website. So we have seen that people get creative replacing websites, so either by hacking DNS or by hacking lower parts of the infrastructure. So we have seen issues with EtherDelta and even with my Ether wallet, I think, some weeks ago. So here, U2F can help because you will receive on the web origin, so the hardware wallet or the device will be able to check which website the user is interacting with, which is a hard problem initially, so it's hard to solve. But in order to properly verify that the hash matches the website you are interacting with, you need to have a trusted store of web origin hashes. So you basically move the problem from not knowing anything to needing centralized stores, so it's not exactly good. Verifying that you're interacting with the right smart contract, so ENS helps on the host, but on the device, it doesn't help much if you don't have this registered origin either. And, well, it couldn't prevent typo squatting. That's something that people have been exploiting on regular desktop applications as well. So that's good, but not enough if we want to properly protect the users. Let's say now, if we want to interact with tokens, we have kind of the same problem. So we need to verify that the token name is matching the right contract address for this token. So we could have a trusted store as well, but then we have again a centralized problem, and how can we solve that? Third, so last problem when we are interacting with a smart contract, we are going to call a function, and we want to verify that the function that we are calling is actually the right function, because otherwise a smart malware could start pinging you and asking you to do something on the contract while you are interacting with another part. So presenting a high-level version of the ABI is nice enough, but if you want to have a proper UI and if you want to actually the user to understand what they are signing, you need something a bit more specific. So there is already a solution which is generic with message chaining, type message chaining with the IP712. It lets you verify everything that an operation would be signing, but it might not be good enough for a proper UX as well, because if you are signing a complex structure like this one, in the end, you don't want to give all these versions, you don't want to give all this information to the user. Typically, you don't want the user to verify the version that they are signing well, you want to have your UI which is exactly matching what the contract is doing, but using a generic API for that is kind of difficult, in my opinion. So the proposal is, since we have seen that we need to decentralize a few things, the main idea of the proposal is to have a new version, to have a new API that will let you design specific application when you interact with a smart contract. So here the smart contract would download a small application living into the hardware wallet that will manage the specific UI parts of the contract. So that way, if we manage to agree between different manufacturers, we could load some kind of bytecode that would represent what the contract is actually, how the UI of the contract is actually played on the hardware wallet, and move from there and have a really native UI regarding to the contract that would, solve that problem and solve the different scams that people can run on contracts. So what is this API going to look like? That's kind of an open question. We will offer a framework to do that in C, so with our own SDK. But people might want to think about a way to actually write some kind of standard to think about how those applications could be coded for the hardware wallet. So on our side, the way we will do it, so we will turn our Ethereum application into a library. That's an operation we have already done with Bitcoin. So you will be able to load small applications that call back to that library for everything that's common to Ethereum and implement a specific contract UI into this application. So you will load the application alongside the contract, delete it when you don't need it, and this way provide a completely native UI when interacting with the application. So I had one slide about our architecture, but then since I am a bit short on time, I will skip it. So thank you.